All right, guys, we're going to begin our unit on acids and bases. This is an introduction. I think you guys will find this pretty easy to understand. You guys have had some familiarity with acids and bases. It says it's our sportiest model, fuel injection, rear spoiler, racing stripes, and special compartment for speed demons. Okay, so you guys, first thing, subheading is acidic solution. So we're going to look at some of the properties of acidic solutions. What is it that makes, what are some characteristics of it? And then ultimately, what is it that makes acids? First thing, you guys have actually seen this before. Acids tend to react with certain metals like zinc, magnesium to produce hydrogen gas. Let me show you an example of that. You guys, we've seen this countless times. This is a pretty typical reaction. So we have here. I just have some hydrochloric acid. Typical. It's a strong acid. We'll talk about what is it that makes it strong in the subsequent lesson. But then I have some magnesium here, or actually no, I'm sorry. I have some zinc. So I'm going to add the acid to the zinc, and you guys, we've seen this before. And typical fashion, we see bubbles, and so we know there's a gas being produced, which is evidence of a chemical reaction. And as that indicates, what's the gas that's being produced when an acid comes in contact with a metal? It's hydrogen gas. You guys can see what kind of problems that this can pose. You think about, you guys have heard of acid rain. What happens is you have pollutants that industry creates, nitrogen dioxide, sulfur dioxide, and then that collects in the clouds, and then when you have precipitation, when the water begins to form, those gases dissolve in the water, and then it produces acids. Like sulfur dioxide would produce, for example, sulfuric acid. Now, and then it'll come down as acid rain. Obviously, you're thinking sulfuric acid, in that with the component of car battery acid. It is, but it's not like acid rain's going to come down. You're like, ah! You're going to be screaming because it's going to be very, very dilute. But nonetheless, and then you can see the damage it can cause. Think about the acid rain coming on bridges and other, metallic structures, and you can see the reaction that would take place. And just to confirm that it's hydrogen gas, you guys remember hydrogen is flammable? No, I should do it with a splint. That would be better. Give me a second, guys. Almost. So I'll light a splint. So you guys, at this point, we should know that hydrogen is flammable. So how I would know this is not like carbon dioxide or oxygen. You guys hear that little pop? That's kind of the typical pop test. So I'm obviously not generating too much hydrogen, but you can at least hear the pop of the hydrogen combusting. Okay. Another characteristic, I'm going to skip that. Acids turn blue litmus red. Okay, so guys, litmus is actually a naturally occurring substance that you'll actually find on moss or lichen. You guys know the kind of stuff, the greenish stuff that might grow on rocks that are really moist. It produces a substance called litmus, and litmus is actually, what's interesting, it can be used as an indicator, because what the compound does, if something's an indicator, in this case, it can indicate whether an acid is present. So when we say blue litmus, so basically you can have some blue litmus paper. I don't know, it looks kind of purplish, but it's dipped in litmus. And litmus is a compound which will actually change colors depending on what kind of environment it's in. And so what we found is that blue litmus, when placed in an acid, so look, I have an acid here, okay? So I'll put it in there, and you guys will notice it turns red. So a good way to remember this, think, right, blue litmus and acid, think acid red. Acid red. You guys know the color coordination, notice that? Okay. So if I had an unknown solution, let's say I didn't know what the solution was, I put blue litmus in it. What can I conclude? Oh, this must be an acidic solution, okay? So we can use litmus paper to help identify a substance. Okay, and there's another characteristic that you guys should be familiar with acids. Think about it. You guys know acids, some acids you can consume. Now really what makes the difference between acids you can consume and ones that will hurt you. Obviously, it'll be the type of acid, but more so it's the concentration. So obviously, if you guys are going to consume acids, it's going to be at low concentrations. Think about all the things that you guys know are acidic. Think about, what are you guys thinking about? Probably lemons, oranges, right? Citrus fruits. Some of you guys might even think vinegar. Vinegar is actually an acid. It's actually acetic acid, dilute acetic acid. What's characteristic of all those things that we just stated? They taste sour. So acids taste sour. Somebody say, well, oranges don't taste sour. You guys, really the difference is oranges are probably just as acidic as lemons. Really the only difference is that the oranges have a lot of sugars that dominates the flavor, so that way you might not taste it to be sour. So typically things that are sour, good indication they're acidic. Okay, and then this is something you guys might know. Acids neutralize bases. We're going to show you here shortly how that happens. So for example, because you guys, both acids and bases can be potentially dangerous, and you could use one or the other to neutralize the other. Okay, so now those are some properties of acidic solutions. So now what is it that makes acidic solutions acidic? It's essentially this, guys. The common feature of acids, it's H+ ions. It's the presence of H+ ions. And you think about these H+ ions, think of it as a hydrogen, and think how did it become a positive charge? It had to have lost an electron. If a hydrogen, remind you, is the simplest element, contains one proton and one electron. Remember, it doesn't even have a neutron. It has one proton, one electron. And if it's positive, that means it lost its electron. Therefore, essentially, what is an H+ ion? It's essentially a naked proton. Think about it. That's a very reactive particle. So that would help explain why acids tend to be so reactive, because of this substance that's present, right? It's going to come in contact with almost anything it comes in contact. What's it going to want to do? It's going to want to take electrons from whatever it comes in contact with. That's what, in a sense, makes acids as reactive as they are. So, put this, guys, the higher you guys remember when we put something in brackets, that means concentration. The higher the concentration of H+ ions, the more acidic the properties, right? We showed the properties. The more reactive it is, the more it's going to react with metals, for example, to produce hydrogen gas, the more sour it might be. So it all has to do with the presence of these H+ ions. Okay, so hard giving up meat for Lent. Isn't that a hamburger? No, it's a cheeseburger. So he's all good. All right, so then lastly, we want to look at bases. You guys, another word for a base is alkaline. I don't know where, maybe you guys have heard of alkaline before. For example, you guys heard on batteries. Batteries can be called alkaline batteries. That just means they have basic components. The components that make it up, it's in a basic environment. Another place where you guys have heard this is, you guys remember on your periodic table, think about the names. Remember, these are called alkali metals, the leftmost metals, and then the second leftmost are called the alkaline earth metals. The reason why that's called is because when you place those metals in water, it will tend to make the water basic. And so we're still going to show you what is it that causes a base to be a base. So first we're going to show some properties of bases. Bases, on the other hand, turn red litmus blue. Notice the color coordination. Think basic blue, think acid red. So let's say I have a base and red, and I have a red litmus. So now red litmus is a different, color litmus, but it's litmus nonetheless. It's an indicator, once again, because it can help us to indicate whether something's acidic or basic. I place it in here, and the litmus changes from red to blue. What would that indicate? That this is a base. Okay, just want to be clear though. Let's say, okay, what did I want to say? Oh, so let's just say we had an unknown solution. So we have an unknown solution, we want to try to figure it out, okay? So we have an unknown solution, and then let's say I just start with a red litmus. So I have an unknown solution, I have a red litmus, okay, and I put it in there, and then what do you guys notice? You guys notice nothing happens. Think about, what do you guys think you could say about this solution? Remember, we said if it's an acid, or if it's a base, it's going to turn red litmus blue, right? Turn blue. Let me ask you guys, so if we view this, can we say that this is an acid? The answer is no. What's the only thing we can conclude from this test right here? The fact that it didn't turn red litmus blue, all that tells me is this is not a base. But I can't necessarily assume it's an acid. How could I confirm if it's an acid? What could I do? You guys remember? You could use, I kind of running out of litmus paper. I could use blue litmus, and then I could put it in there, and once it turns it red, then that confirms, okay, this is an acid. You guys see why I couldn't do that at the beginning? Because you think about it, guys, there's actually, think about a solution, can either be acidic, basic, but could it be something else? Couldn't it be neutral? So that's where you couldn't conclude unless you did both those tests. All right, bases, give you guys a hint, think about, you know, a base, a soap is a base. So you think about soap, how would you guys describe soap? Soap has typically like sodium hydroxide, which is a base. Bases tend to be slippery, okay? And you guys, this is something, the next one is something I'm familiar with. You guys think about, when it comes to, you guys remember acids taste sour. How do you guys think bases taste? Well, you kind of compare it, you're like, remember I just said a lot of soaps are basic, so you're like, how would I know how soap tastes? If you guys were like me when you were a little child, you know, you kind of learn new words, and I would kind of use, you know, bad words that I just, let me do something here real quick, guys. I remember, this sounds really bad, but I remember learning for the first time, well, you know what, I'm going to leave that out. All I'm going to say is, those of you guys who used bad language in the past, you might have had your mom like my mom. She heard me say a word, and she said, did I hear you right? I said, yeah, I said that. And so, I don't know about you, but she took soap, not like the liquid soap. Liquid soap would probably be a little bit better. She took a bar soap, and she just like started grinding it all in my teeth. You guys heard of that, right? Parent, wash your mouth out with soap because you got a dirty mouth. You know, and I didn't like it at the time, but I know my mom did it because she loved me, right? And so now, obviously, I don't curse nearly as much, hopefully not at all. But anyways, I know distinctly how soap tastes because it was like grounding my teeth. So you try to get it out, and you just want to throw up. Those of you guys who had the experience, you know what I'm talking about. If you haven't had that experience, you have no clue what I'm talking about. But what is the taste? Soap tastes bitter. So these are some of the properties of basic solutions. And then just as acids neutralize bases, bases neutralize acids. And so we're going to show you how that works. So this is really a big one because, for example, in the classroom, we might be working with acids, right? And occasionally somebody would have an acid spill, right? So the question is, how are you going to clean up an acid spill? You don't want to just take a paper towel. Remember, I said bases can be just as reactive and as dangerous as acids. You don't want to just take up a paper towel because it could react with a paper towel. You definitely don't want to come in contact with it because it could do some damage to your skin. So what could we do? We could neutralize the acid. So what I do have is, you guys, a typical weak base is sodium bicarbonate. You guys, that's like your baking soda. And you might have in your refrigerator, right, to kind of kill the odors. It's baking soda. It's a base. So I actually have some baking soda in the back of my lab station. So if a student were to have an acid spill, we would take some of that baking soda, which is a base, and we'd put it onto that acid, which would help neutralize it before we would clean it up. So here's what makes bases bases. A common feature is it's these hydroxide ions. Remember, this was a polyatomic ion we learned first semester in the nomenclature unit. Bases deliver to water hydroxide ions. In fact, that's what happened. You guys remember what I was saying? The reason why these are called alkali metals and these are alkaline earth metals. When you put those in water, you'll actually have the formation of hydroxide ions. And obviously, where did these come from? It came from the water itself, as the metal reacts with the water, and then you produce these hydroxide ions. And these, you guys can imagine, these are very reactive as well. Just like the H plus ions are reactive in the acids, the OH minus ions, you think about when they come in contact with something, what are they going to want to do? They're going to want to, just like the H plus wants to take electrons, this is going to readily donate electrons to others and thus be relatively reactive. And in typical fashion, what we said, we already wrote this. Well, when it comes to a base, think about it, you guys could fill this in. When it comes to a base, the higher the blank ions, the more the blank the properties. The higher the hydroxide ion concentration, the more basic the properties. Okay. You guys notice we said they neutralize each other. Here's why. Think about it, guys. What makes an acid an acid? You would think the presence of H plus ions. And then think about when that comes in contact with a base, right, which is going to have hydroxide ions present. I'd write this down, guys. Hydroxide ion present. You guys think about it. What do you think those are going to do? Think about H plus ion, combines with a hydroxide ion. What do you guys think? Combines, what's it gonna make? You guessed it, it's gonna make water. Okay, so that's how they neutralize each other. The hydroxide ions will combine with H+, take those out of solution, or the H+ will take the hydroxide ions out of solution, combine together and form something. So you have something very harmful that's very acidic, combined with something else that's very harmful, very basic. You put them together, and what ultimately you end up with, it's actually water and a salt. I don't want to confuse the issue, but if you just think about that's kind of the main reaction happening. You form water. That's the neutralization process. All right, guys, we are done for today. Thanks for hanging out. We'll see you next time.